All right, so in this video, I'm going to talk about how to interpret the results in Jamovi for a chi-square goodness of fit test. I conducted that in the previous video. And again, this test is to determine if sample data fits a hypothesized distribution or a population distribution. So we're looking at observed versus expected frequencies. So these are the results that I got in the previous video. And you can see that the way this is set up, we can see an observed and expected frequency for each category. So in this case, we're talking about first generation status. And here you'll see that this is the no category right here. And then this is yes category right here. So we observed, this is our actual sample. We had 15 people in our sample that said no, they're not first generation students, which ended up being 0.43 or about 43% of our sample. If the proportion in the sample was the same as in the population for no, which would be this 35.90, or 0.3590, which is this right here, then we would have expected to get about 13 people in that category. And then you can see down here in the yes, we observed 15 people. So this is what we actually, I'm sorry, 20 people. This is what we actually had in our sample, which makes up about 57% of our sample here. We would have, if it were the same as our population, we would have expected to get about 22 people, which is that 64.10% or proportion of 0.64. Now, the part that tells us if this is a statistically significant difference, it's so different that we can consider it meaningful. We look at our chi-square goodness of fit. So this is our chi-square test statistic that you would report. Chi, not chi, not chi, not even to tease me in class. Stop it. Then this would be our actual value, and it's an evaluation of the expected versus observed proportion. So it's comparing the expected versus the observed. So observed in the sample versus expected based on our proportion in the population. Now, we also have our degrees of freedom here. It's the number of groups minus one, or k minus one. And then we have our p-value, which is 0.39. So because our p-value is quite large, we can say that what difference there is, we think it's pretty likely that we just observed that by chance, and that it just reflects sampling error rather than any real difference. So this is relatively simple to interpret. And in the next video, I'm going to show how to write about this in APA style.